When questions start to get complicated and give a lot of information, the secret is to be able to pick out from all the information the bit that you need. So let's look at the first question. It tells you the mass of the car, it says it's accelerating, it gives you the speed at the start, but it sort of implies it says it's at rest, and it tells you the speed that it gets up to and how long it takes. And the first thing it asks is the acceleration of the car. And the important thing to realise is that you don't have to use all the information. Okay, it tells you what the mass is, but you don't need to know that. If you know that a car is starting at rest and 50 seconds later it's going at 12 metres per second, that's all you need to know to find the acceleration. So it just goes back to being a straightforward SUVAT question. So you can write down SUVAT as we've been doing on the other examples, and you'll find a value for the acceleration of the car. When you come to part B, you've got to find the force that caused the car to have that much acceleration. Well, what does the question tell you? Well, it tells you the mass of the car, and you've worked out what its acceleration is. Now, when you know mass and you know acceleration, it's really easy to find the force that causes the acceleration. It's F equals ma. Part C is a little bit more complicated. It looks complicated, but let's think what you've got so far. So far you've worked out the force that's driving the car forward and making it accelerate. That's what it calls the accelerating force. The question also says you need to know the weight of the car. Well, it's easy to find the weight of something if you know its mass and you know how strong the gravitational field is, which is given there at the top of the question. You can find the weight. The weight of the car's got nothing to do with the way it accelerates, but you can find it out. Mass times gravitational field strength. So when you've done that, you know two forces. You know the force that's driving the car forward, making it accelerate, and you know the weight of the car. When you've got two forces, to find the ratio, you just divide them. So if you know the accelerating force, you know the weight of the car, you divide the accelerating force by the weight of the car, and you get just a number. Because remember, a ratio is just a number. If I'm 2.5 times as old as you are, the ratio of my age to your age is just 2.5. If you're 0.4 times as old as I am, the ratio of your age to my age is just 0.4. So if you've done question 1 okay, you can do question 2 just as easily. It tells you the aeroplane, it tells you what its mass is, it tells you that when it hits the runway it's going at 60 metres per second, and that it takes 25 seconds to stop. And the first thing it asks for is the deceleration. Well, we know what that really means. We're really trying to find the acceleration, and we know we're going to get a negative value because it's slowing down. So just like the last question, you can ignore the mass. To find the acceleration, all you need to know is what was the speed to begin with, what was it later on, and how long did it take for that change to happen. So you can find that part easily enough. And then, next part, the braking force of the aircraft. You know its acceleration, so you know there must have been a force causing that acceleration, and you know that the connection between an acceleration and the force that causes it is F equals ma, so that's really easy. Question 3 makes things a little bit more complicated for you, because it asks you straight away to find the force. So what you need to know is that the only equation we've got that connects force with movement, it's force equals mass times acceleration. And the question tells you the mass, but it doesn't tell you the acceleration. But it tells you all you need to know to find the acceleration. You know that it starts at rest with a speed of 0, it speeds up to have a speed of 6 metres per second, and it takes 20 seconds to do that. So you know the change in speed, you know the time, so you can find the acceleration for yourself. And once you've found the acceleration, that's when you use F equals ma to find the force. So don't try and do it all in one step. Actually work out the acceleration and write acceleration equals, and then use that. find the force. Right, question B. Lots of words in here. The vehicle's fitted with a trailer. It tells the mass of the trailer. Calculate the time taken to reach a speed of 6 meters per second from rest for the same force as in A. So it says the force is the same as in A. What difference does the trailer make? Well, the trailer means that that force, instead of just acting on 1200 kilograms of car, that force is acting on 1400 kilograms of car and trailer together. So the same force, a bigger mass, that means you can find out the new acceleration, which of course will be less than the one you had before. And now you know the acceleration, and you know that the car's got to speed up from rest to 6 meters per second. So you know the change in speed, you've already found the acceleration, so you can find the time. So question 4 talks about a bullet being shot into a tree. And as with the other examples, the secret is to be able to pick out which bit of information we need when. So the first thing it's asking for is the deceleration of the bullet. In other words, it wants to find the acceleration, and we know it's slowing down, so it's going to be a negative acceleration. So we pick out what we need to know. Do we need to know the mass to find the acceleration? Well, that's what it tells us. It tells us the speed at the start, and it tells us how far it travels while it's slowing down. So really, it's a SUVAT question. Now, lots of the others have been SUVAT questions, but they're quite straightforward. For this one, I think it is worth going to the trouble of writing down the SUVAT. So here we are with our SUVAT, so we're writing the values. S is the distance it travels. Well, it tells us how far the bullet's travelling while it's slowing down in the tree. You write it down, I'm just ticking it. The initial speed, it tells us how fast the bullet's going when it hits the tree. The final speed, well, it tells us that the bullet, or it implies that the bullet's coming to rest. So we'll know the final speed. The acceleration, we don't know. We know it's negative, which is why the question calls it a deceleration, but we don't know its value. The time, well, we don't know that, but we're not particularly bothered actually about the time. So now we need to choose our right equation. Well, given that we don't know the time and we don't care anything about the time, all we know or care about is S and U and V and A. I think it should be quite simple to pick out the equation we're going to use to find A. So I'll leave you to pick that one out. Once you've used the right equation and you've avoided simple errors like you've remembered to make sure the units are okay, so you find the acceleration, which will be negative, so it's why it's called a deceleration. Then all you've got to do is you've got to find the force of the bullet on the tree. Now there's actually a little subtle twist in this really, but I'll talk about that in a moment. We know the acceleration of the bullet, and we know the mass of the bullet, so you can find the force that caused the acceleration. And don't worry about whether it's positive or negative. We know what the tree's doing. The tree's slowing the bullet down. So if you happen to put a negative sign in the acceleration, you get a negative value for the force, but don't worry about that. Just remember common sense. Bullet's hitting the tree and the bullet's slowing down. All we need to know is how many newtons are there. The slight little subtle twist to the question is that if you use F equals ma, that tells you the force on the bullet. The question actually asks for the force that the bullet puts on the tree. So if you've worked out the force that the tree puts on the bullet, it's very simple to find the force that the bullet puts on the tree. But there is one of the laws you've got to apply so that you know why your simple answer is right.